This is mathheals.com, where you can find more links to math and computer science YouTube videos. Let's take a look at simplifying expressions using laws of exponents. And let's first just refresh our memory on some of them. I'm not going to put all of them here. Our first one, if we have x to the m power times x to the n power. Now these do not have to be x's, they can be anything, just as long as they're the same. And you multiply these together, then you can add the exponents. So this becomes m plus n. Now if you have x to the m power over x to the n power. Well, multiplication becomes addition like that, and division becomes subtraction. So this would be x to the m minus n. Now there's an easier way of thinking of this type, which we'll see. Our third one, if we have x to a power raised to another power. Well, if you raise one exponent to another exponent, you multiply the exponents. Now I'm actually going to put a number here. But let's say you have a negative exponent. For example, you have x to negative 2. Well, in this particular case, first thing we'd do is we would write that in fraction form. So I'll put this as x to negative 2 over 1. And to get rid of a negative exponent, you take the part that has a negative exponent opposite of where it's at in a fraction. So the x to negative 2 I take down to the denominator. And when you do that, it becomes a positive exponent. So it becomes x to the positive 2. And then you have a placeholder of 1 in the other place. Now, on the other hand, if we start out with a negative exponent in the denominator, we move it up on top, and it becomes x to the positive 3 over 1, which is just x to the 3. This is written different ways in different books. But let's say we have x times y inside of parentheses raised to the m power. Basically, if everything inside your parentheses is either multiplied together or divided, so you have multiplication division, and you're raising it to a power, you take everything to that power. So we take x to the m power, and we take y to the m power. And one last one. Like I say, this isn't all of them, but this will get us started. Oops, I meant to put a number there. If we have a fraction to a negative exponent, you flip the fraction, take the reciprocal of it, so the x over y becomes y over x, and the sign of the exponent becomes positive. Now this is the main properties that's going to be shown in this section. They're just going to be a little bit different because they'll involve fractions. So let's look at our first one here. Got 2 to the 1/4 times 2 to the 11/4. Now remember from our first property here, if these are the same and you multiply them together, then you can add the exponents. Since these are both 2 to a power, I can add the exponents. So this becomes 1/4 plus 11/4, which gives us 12/4. And 12/4 is 3, and 2 to the 3rd power would give us 8. Our second example here, we got 5 to the 9/2. Excuse me. Still a little bit sick. Okay, well this is our second property. If these are the same, these are both 5 to a power, then what you do is you subtract a smaller exponent from the larger one. So we got 9/2 minus 5/2, and that's going to give us 4/2, or give us 2. And then we're going to have 5 to that power where our larger exponent was. Well, our larger exponent was up on top. So it becomes 5 squared up there, and we put a placeholder of 1 here. Again, if these are the same, 5 to a power over 5 to a power, x to a power over x to a power, you subtract a smaller exponent from a larger one, like we did here, and then you have 5 to that power where your larger exponent was, which was up on top. I don't use this property, number 2. I go along those lines. Well, 5 squared is 25, and that's our answer. let's see, we've got 5 to the negative 7/3 times 5 to the 2/5. Well, we never want negative exponents. So the first thing I'm going to do here is get rid of those negative exponents. Well, to get rid of a negative exponent, you need to take it opposite where it's at in a fraction. But first thing we have to do is put this in fraction form. Well, you can always create a fraction by putting it over 1. So I put that over 1 like that. And now we're going to take the part with the negative exponent, that's 5 to the negative 7/3, and we'll take it downstairs. So we're going to have 5 to the 2/5 over 5 to the 7/3. And we got rid of our negative exponent. Now we know, since we have 5 to the power and 5 to the power, we're going to subtract a smaller exponent from a larger one. But it really does work out best if they have the same denominator. See how this is 2/5 and this is 7/3? I'm going to rewrite those with a common denominator, which would be 15. Well, up on top here, we multiplied the denominator by 3, so we have to multiply the top part by 3. 2 times 3 gives us 6, so we've got 6/15. On our bottom part here, we multiplied the denominator by 5, so we have to multiply the top part by 5. So that becomes 35 over 15. Well, now it'll be easy to work with. We've got 5 to the power of 5 to the power, so I'm going to subtract a smaller exponent from the larger one. So I got 35/15 minus 6/15, which gives us 29/15. So we're going to have 5 to the 29/15 where our larger exponent was, which was down in the denominator. So we'll have 1 over 5 to the 29/15. And that's our answer. Okay, let's look at this one. We got y to the 1/3 over y to the 5/12. Well, again, the fact that they're both y to a power, I'm going to subtract a smaller exponent from a larger one, but it does work out best if they have the same denominator, the exponents that is. So I got 3 and 12. My common denominator would be 12. Now the bottom one already had 12, so we'll leave it alone. It's 5/12. On top exponent here, we multiplied the bottom part by 4, so we have to multiply the top part by 4. So that becomes 4/12. Well, we got y to a power over y to a power, so we're going to subtract a smaller exponent from a larger one. So we've got 5/12 minus 4/12 gives us 1/12. And we'll have y to the 1/12 where our larger exponent was, which was down below. And then we'll put a placeholder of 1 there. And that's our answer. Let me double check to make sure I got this these pages saved off. I'm redoing these in YouTube format. They were just in WebEx format. Looks like I do have them here. So let's look at our fifth one. We got 16 to the 7/12 raised to the 6/7. Now remember before we said that if you're raising one exponent to another exponent, you multiply the exponents together. And that's what we'll do here. So we've got 16 7/12 times 6/7. Well, we can simplify this a little bit. The 7's cancel. And that's going to give us 16 to the 6/12 power. Well, 6/12 reduces. Top and bottom both divisible by 6. That gives us 16 to the 1/2. And now we can put this back into radical form and simplify it. So put a 2 here, put a 1 here. Now remember the way it works. Whatever number is up on top here in numerator goes inside as your power. Whatever number down here, your denominator, is what goes in the little slot here. That's called your index. And we know if our index is 2, that's automatically a square root. And 16, the first power is 16. Well, square root of 16, we think 16 is 4 times 4. With square roots, we're looking for a pair of somethings. Here's a pair of 4s. So a pair of 4 is going to come out as a single 4. And that's our answer. Okay, let me see. We got 25 to the negative 1/3 times 5 to the 11/3 to the negative 2 power. Well, there's different ways of working these problems. Typically, I try to ignore shortcuts I may see, and I try to follow my order of operations. Please excuse my dear Aunt Sally. Remember, your order of operations says do what's inside the parentheses first. So let's focus on what's inside the parentheses. Well, inside of the parentheses, I notice I got a negative exponent. Well, I know what I need to do there. I need to get rid of that negative exponent. So I'm going to rewrite that in fraction form, putting it over 1. Now we know to get rid of the negative exponent, we take the part with the negative exponent opposite of where it's at in a fraction. So the 25 to the negative 1/3, I'll take down to the denominator. And this becomes 5 to the 11/3 over 25 to the 1/3. All of it raised to the negative 2 power. Well, if this was 5 to a power and this was 5 to a power, it'd work out very, very nice in this problem. Well, that's easy enough. 25 I know is 5 squared, so I could rewrite the 25 as 5 squared. And there we go. So we got 5 to the 11/3. Remember, when you're raising one exponent to another exponent, you multiply the exponents. So 2 times 1/3 gives us 2/3. So we got 5 to the 2/3. All of it raised to negative 2 power. Still doing what's inside the parentheses. That's what order operation says. We have 5 to a power over 5 to a power. So we're going to subtract a smaller exponent from a larger one. So we got 11/3 minus 2/3, which gives us 9/3, which gives us 3. Which means we're going to have 5 to the 3rd power where our larger exponent was. Our larger exponent was up on top, so we got 5 to the 3rd up there, and we got a 1 down here. Now I could go ahead and take 5 to the 3rd and rewrite it as 125. And technically that's what we would do, but I know that if we have a fraction to a negative power, you flip the fraction, take the reciprocal of it, so this becomes 1 over 5 to the 3rd, and you change the sign to that exponent to 2. Now earlier I said if everything inside your parentheses is multiplication and division, you're raising it to a power, you take everything to that power. So I'm going to take the 1 to the 2nd power, and I'll take the 5 to the 3rd to the 2nd power. Well, 1 squared is 1. And here we're raising one exponent to another exponent, so you multiply the exponents. 3 times 2 gives us 6. So we're going to have 5 to the 6. And I have no clue what that is. Where's my calculator? There it is. So 5 to the 6th power. Ooh, that's kind of huge. So this becomes 1 over 15,625. There's different ways you could have worked this problem. Again, I try to follow my order of operations so you can see that there's one set path you can always follow. Sometimes I slip and I want to use the shortcuts. Okay, let's look at the next one here, number 7. Got a to the 5/2, b to the negative 1/3, times a to the negative 3, b to the 10/3. Okay, now I know there's multiplication here, but my dear Aunt Sally, order of operations, says do what's inside the parentheses first. Well, we got negative exponents, so I'm putting them over 1. So we got a to the 5/2, b to the negative 1/3 over 1. And here we got a to the negative 3, b to the 10/3 over 1. Now we take the part with the negative exponent opposite of where it's at in a fraction. So we'll take the b to the negative 1/3, move it down to the denominator. Take the a to the negative 3, move it down to the denominator. Okay, so we got a to the 5/2 over b to the positive 1/3. Remember, you take anything opposite where it's at in a fraction, the sign of the exponent changes. And we got b to the 10/3 over a to the positive 3. Well, there's nothing left to do inside each set of parentheses, so now we'll handle the multiplication. And I could go ahead and simplify this, but let me go ahead and write it as a single fraction first. So in multiplying these two fractions together, I just multiply the numerators together, the top parts, and then the bottom parts. And multiplying those together, you just rewrite them next to each other, since they're different letters. Now this a to the third, I'm going to rewrite that as a to the 3 over 1. Now the reason why I do that is because I have a to a power over a to a power. I know I'm going to subtract the exponents, and I know I need to have a common denominator. Now b's are okay already. This is 10/3, this is 1/3. They already have a common denominator. But let's work on the a's. Our common denominator would be 2. So this is a to the 5/2, b to the 10/3, over b to the 1/3, a to the... And here we multiply the bottom part by 2, so we have to multiply the top part by 2, so we get 6 over 2. Okay, let's start with the a's first. We have a to a power over a to a power. We're going to subtract the smaller exponent from the larger one. So I got 6/2 minus 5/2, which gives us 1/2. So we're going to have a to the 1/2 where our larger exponent was, which was downstairs. Now let's look at our b's. We're going to subtract the smaller exponent from the larger one. So we got 10 over 3 minus 1 over 3, which gives us 9 over 3, which gives us 3. So we're going to have b to the third where our larger exponent was, which was up on top. And that's our answer. I don't think it wants us to rewrite it in radical form. No, it just says simplify. Let me start a new page. Excuse me. Okay, so we got 36 m to the 1/4 n over m to the negative 3 n to the 8/5. All of it raised to the 1/2 power. Well, again, my order of operations says do what's inside the parentheses first. Well, there's a fraction in there. When handling fractions, you do the top part separate from the bottom part. Well, there's nothing to do on the top. On the bottom, there's nothing to do except for get rid of the negative exponent. So I'm going to take that m to the negative 3 and move it up on top. So we got 36 m to the 1/4, m to the positive 3, n to the 1 power, over n to the 8/5. All raised to 1/2 power. Well, I need to get some common denominators here. So this would be 36 m to the 1/4, and this would be m to the 3 over 1, and this is the n to the 1 over 1, over n to the 8/5. Okay, let's look at the m's first. Now I got 1/4 and 3 over 1, so my denominators are 4 and 1, so my common denominator would be 4. So I got m to the 1/4 and m to the 3 over 1. I multiply the bottom part by 4. To get the common denominator, I have to multiply the top part by 4. 4 times 3 is 12, so that gives me 12/4. Now the n's. I got 5 and 1. My common denominator would be 5. So on this one, I multiply the bottom part by 5, so I multiply the top part by 5. So this becomes n to the 5 over 5, and then n to the 8/5. Well, now we're ready to do some combining. Look at the m's first. We got m to a power times m to a power. You're going to add the exponents. So 1/4 plus 12/4 gives us 13/4. Like that. And the n's. We got n to a power over n to a power. We subtract a smaller exponent from a larger one. So we got 8/5 minus 5/5, which gives us 3/5. And we have n to the 3/5 where a larger exponent was, which was down denominator. Now there's nothing left to do inside of the parentheses, so I'm going to handle the exponent on the outside. Now if everything inside your parentheses is either multiplication or division, you're raising it to a power, you can take everything to that power. So we'll take 36 to the 1/2 power. We'll take the m to the 13/4 to the 1/2 power. And we'll take n to the 3/5 to the 1/2 power. Well, 36 to the 1/2 power is the square root of 36. And the m to a power raised to a power. When you're raising one exponent to another exponent, you multiply them together. 13 times 1 is 13, 4 times 2 is 8. So this becomes 13/8. Down here at n, again, I'm raising one exponent to another exponent. I multiply the top parts. 3 times 1 is 3, 5 times 2 is 10. So we got 3/10. Now, square root of 36 is 6, so we can simplify that. So we got 6m to the 13/8 power over n to the 3/10 power. And that's our answer. Go ahead and save that. Let's look at our next problem. Now these next problems give us the problem in radical form, and we want to use rational exponents to do some simplifying. Now there's some properties you can use dealing with radicals on these, but they specifically want us to use rational exponents. So it says use rational exponents to simplify each radical, assume all variables are positive. Well, we can write this in rational exponent form, fractional power. This becomes 25 to the 6/12 power. Whatever power is inside here goes up on top, if there is a power. If there isn't one, that's by default 1. And then whatever's in your index here, here's a little slot, that goes in your denominator. Well, after I rewrite it in that form, I see I can simplify that. 6/12 is 1/2, so this is 25 to the 1/2. And now I'll put it back into radical form. Again, whatever number is up on top here is your power. Whatever number is on the bottom is your index. Number goes in that slot. And if you got 2, it's a square root, so this is just square root of 25. Which 5 times 5 gives us 25, so this gives us 5 as our answer. Let's look at this one. Square root of 36 x to the 10th, y to the 18th. And again, they want us to use rational exponents to simplify this. Well, rational exponents don't work well with numbers like this. So we can go ahead and simplify that. 36 is 6 times 6, x to the 10th, y to the 18th. Remember the square root, we're looking for a pair of somethings. Here's a pair of 6's, so that's going to come out as a single 6. Now this is a square root, so I'm going to put a 2 here just to really emphasize the index. If you got a square root, it's by default 2 for the index. X to the 10th, y to the 18th. Well, I want to write these in rational exponent form, so this becomes x to the 10 over 2 power and y to the 18 over 2 power. Again, whatever your index is goes in your denominator. Whatever power is on the particular variable is what goes up on top in the numerator. And after I do that, 10 divided by 2 is 5, so this becomes x to the 5th. And 18 divided by 2 is 9, so this becomes y to the 9th. And that's my answer. Okay, let's look at this one. Cube root of y to the 5th over the 5th root of y. And they want us to use rational exponents, so that's our starting place. We'll rewrite the top part as y to the 5/3, and the bottom part becomes y to the 1/5. Again, whatever number is in this little slot here, that's your index, goes in the denominator. So 3 goes in the denominator, and down here the 5 goes in the denominator. And then whatever power is inside goes up on top. So I put 5 here, and I put 1 here. There was no power, so it goes to 1 by default. Now we got y to a power over y to a power. We saw these earlier. We need to get a common denominator. Well, I got 3 and 5, so my common denominator will be 15. So this will be multiply the bottom part by 5, multiply the top part by 5. This will be y to the 25/15 over, Here I multiply the bottom part by 3, multiply the top part by 3. So that gives me y to the 3/15. Well, now we have y to a power over y to a power. I'm going to subtract a smaller exponent from a larger one. So I got 25/15 minus 3/15, which gives us 22/15. So we're going to have y to the 22/15 where our larger exponent was, which was up on top. So we got y to the 22/15, and I'll put a placeholder of 1 here, which is just going to disappear in the next step. So this becomes y to the 22/15. Now the instructions don't really indicate whether to put it back in the radical form or not. So the answer might be that, or we could put it back into radical form like this. And since we really haven't talked about simplifying these, then that would be our answer. We're going to see, I think in the next section, you can actually bring 1y out, because our index is 15. We're looking for 15 y's. Well, we have 22 y's, so we can bring 15 of those out as in front as a single y. Let's look at our next one here. Look at the 5th root of the square root of x to the 5th. Well, let's first start with the inner part. So I'll leave that outer radical alone, and this becomes x to the 5/2. Again, whatever number's in the little slot right here, there is no number, so it's by default a square root, so it means it puts 2 in the denominator, and then the power here goes up on top. So now we're going to have x to the 5/2, some power, which would be 1/5. Again, you can put 1 there by default if you put the power inside here, and then 5 comes from the index. We're raising one exponent to another exponent, so you multiply the exponents. So we got x to the 5/2 times 1/5. 5's will cancel, and that leaves us x to the 1/2, which is the square root of x. And that's our answer. If they want a radical form, that is. Okay, let's look at this one. We've got the cube root of 7 times the 7th root of 49. And they want us to use rational exponents. So that tells us where to start. May not know where to go to after that, but at least we want to rewrite it in that form. So this would be 7 to the 1/3 times 49 to the 1/7. Now we've already discussed earlier that if these are the same, then we could do something with them. If this was 7 to a power and this was 7 to a power, well, that's easy. 49 is 7 squared. So I can rewrite it that way. So we've got 7 to the 1/3 times 7 to the 2/7. Now if we got 7 to a power times 7 to a power, we add the exponents. In order to add the exponents easily, we need to have a common denominator for the exponents. Well, I got 3 and 7. My common number would be 21. Now my first exponent here, multiply the bottom part by 7, so multiply the top part by 7. So that becomes 7 over 21. My second fraction, I multiply the bottom part by 3, so I have to multiply the top part by 3. So that gives me 6 over 21. Well, now that they have the same denominator, I can add the exponents. 7 over 21 plus 6 over 21 gives us, what, 13 over 21? And if they want it back in the radical form, that would look like that right there. I'm not sure how they'll want their answer. The book wasn't real clear on the instructions on that. Take a look at this problem. We got 5x to the 3/2 plus 2x to the 1/2 times 3x minus 5. And it tells us to factor out an x to the 1/2. Well, let's think back. Factoring. Well, GCF here was x to the 3rd, and we factored it out. Now, when we factored it out, we had x to the 6, took 3 x's away, it leaves us 3 x's. minus 2 here. If you think about what you did here, you subtracted the exponents. 6 minus 3 gave us 3. 3 minus 3 gave us 0, so we had x is 0, so the x's disappeared. So that's what we're going to do when we factor this out. We'll subtract the exponents. So I got 5x. 3 halves minus 1 half gives us 2 halves. Plus 2, then that x to 1 half is gone, times 3x minus 5. Well, 2 over 2 is 1, so this just becomes 5x. And I multiply that 2 through. 2 times 3x is 6x. 2 times negative 5 is negative 10. 5x plus 6x gives us 11x minus 10. And that's our answer. Now, you really don't see this at all in college algebra, problems of this type. But you do run across this a lot in calculus if you go out and take that, whether you take business calc or calc 1. Okay, so let's take a look at another one of those. We've got 2 and then x plus 3 to the 1/3. 5x plus 2 plus 9 x plus 3 to the 4/3. And it says factor out x plus 3 to the 1/3. Okay, well that 2 remains. This x plus 3 to 1/3, that's completely gone. And we're also left with 5x plus 2. Plus 9. Now, we're factoring this out. Remember, you subtract the exponents. 4/3 minus 1/3 gives us 3/3. So we're going to have x plus 3 to the 3/3. So 2 times 5x gives us 10x. 2 times 2 gives us 4. Plus 9 times x plus 3. 3 over 3 is 1, so that just disappears. So we've got x plus 3 to the 1/3. 10x plus 4. 9 times x is 9x. 9 times 3 is 27. (10x plus 9x is 19x. 4 plus 27 is 31. And that would be our answer. And I believe that's the last problem. Yep. So go ahead and save this.